All right. Couple more clicks here and we're ready to go. Attendance, which for you guys is so easy. Thank you. Because you all show up. All right. So we were doing geometric sequences and series. When is school out? Not till June. I know, right? I used to like it when it was out like right before Memorial Day. Things got started late this year. I don't know if it was COVID or what it was, but you know. Anyway, but we're in the last quarter. That's a good thing. All right. All right, so we get about halfway through this. We'll see if we can finish the rest of this up today. So again, a geometric sequence is a sequence of numbers, and you keep arriving at the next number by multiplying by some number over and over. And then we have some sort of starting point, a starting number, and a couple different ways that we can express these. One is what they call the explicit method, which is basically they use n instead of x for like the number in the sequence. And that's just counting numbers. It's like 1, 2, 3, 4, that kind of thing. So you're just plugging in 1, 2, 3, 4 and getting the answers back. The other version is what they call the recursive version. And what that is, that's when you come up with a series and it's pretty much based on the previous term. So to figure out the new guy, you have to use the old guy or the previous generation. So we kind of talked about that a little bit as well. So we're probably just going to be practicing some more stuff like we were. So as you can see here at the side, we got quite a bit done last time. So let's hop in here and take a look at what we're doing here. Okay, so this says, write the expansion of the series and what is the sum? That's different. So what's that all about? All right, so in this case, this is pretty easy because all they're saying is, you see this goofy looking thing kind of looks like an E? Where's my cursor? This guy, right? That is a capital sigma. You'll find out more about these Greek letters when you go to college. Okay? So this is a Greek letter, and the math guys like to use Greek letters mostly because a lot of math came from Greece, and a lot came from Italy, Rome, a lot of Greece, and then also a lot of them came from, believe it or not, Saudi Arabia in the Middle East, and that was primarily the algebra stuff. And then also a lot of stuff came from Egypt, and the Egypt stuff was a little more geometric. And you know how our number system is base 10, like we count to 10 and then we start the next sort of column or row or whatever, you know, tens, hundreds, thousands, that kind of thing. The Egyptians, and I have no freaking idea how they would have calculated anything using this, their stuff was base 60. I don't know why they use 60 other than I think 60 has a lot of different multiples, so maybe they could do like a lot of different fractions with 60. But the thing about it is there's a lot of stuff where we still use a lot of stuff that was based on that 60 stuff, like 60 seconds in a minute, you know, 60 minutes in an hour, that kind of stuff. 360 degrees in a circle, you know, which is basically 6 times 60. So a lot of stuff actually still exists from the geometric stuff, the Egyptian stuff. So just a little side note there. So then all we're really doing here is we're just plugging in the numbers, chugging out the answers, and then adding them all together at the end. So for n equals 1, so a sub 1, helps if I get something that actually writes. One moment, please. So a sub 1 is going to be, we put a 1 in here. Well, 1 minus 1 is 0. 2 to the 0 power is 1, so the first guy is just 4. Okay? So that should be a sub 2, or a sub 1, not a sub n. One moment. Helps if I hit the right thing once in a while. There we go. So yeah, so this would be the first term. Okay? Then we do the second term. So this time we're going to plug a 2 in here. So 2 minus 1 is 1. So 2 to the first is just 2, right? 2 times 4 is 8. Okay. So A3, this time we're going to plug in a 3 there. Okay. So we put a 3 up here. So 3 minus 1 is 2. That's 2 squared. 2 times 2 is 4, right? Times 4 is 16. So we're starting to notice a pattern here. We went from 4 to 8 to 16. And since we're multiplying by 2 every time, basically what we're doing is we're doubling up, right? So A4 would be 32, A5 would be 64, and A6 would be 128. This is called I've done this too much, okay? And then they want to add all these guys together. Okay, so that's enough for me. I guess we'll break out the calculator at this point. And I need to find the calculator since this thing restarted and got rid of everything I had up. Thanks for that. All right, so let's bring the calculator back into play here. Incoming. All right, we need to make him a little smaller so we can work with him. That would be good. All right. There we go. Okay. So we start off with 4. So we're going to do 4 plus 8 plus 16 plus 32 plus 64 plus 128. 252 is going to be our final answer here. Okay, so you see what we did there. So we just kept plugging in a bigger number from 1 to 6, right? And then we added the 6 numbers together. Okay? Any questions on that? All right. All right, so let's go ahead and try another one. This one's going from 1 to 20. Ooh. That's entirely too much, isn't it? So, of course, you know, the math guys are going to sit there and they're going to whine. They're like, I don't want to have to do 20 of these. Are you kidding me? So you know how they are. They come up with another version of this, right? And I tell you what, honestly, I don't remember what it is. But there's a formula for this. So you know what we do when we don't remember the formula? We look it up. So that's what I'm going to do right now. As you see, I don't remember anything I don't have to. Sometimes I don't remember things I do have to. All right, so what section were we on here? I don't even remember anymore. Hang on, let's back it up here for a second. Please. I probably would have looked this up ahead of time, but my computer didn't want me to. So where are we at here? Topic 6-7. Okay. Let me dig this guy up here for us real quick. So it definitely feels like Monday, doesn't it? All right. 6, 7. Okay. All right, so let's figure out the formula here. Okay, I have found the formula. So here's what it looks like. Let me write this sucker down. If you're looking at your book stuff, this is on, what is this? What page is this? 341. So page 341. Okay, So here's how this works. Like I said, you can add them up when it's not a whole lot of numbers like we did, which was pretty convenient. But this guy here, that's too many, right? So here's how they write this. So it's going to be someone calling me that I don't need to talk to right now. Bye. Okay. So the formula is the sum of n number of terms, right, for the geometric stuff. Looks like this. So it's going to be a sub 1, so that's our first guy, right? Then it's going to be 1 minus the common ratio. That's what we're multiplying by over and over, okay? That's what we're multiplying by over and over. And then raised to the n power. Oh man, this is a calculator thing for sure, right? Okay, so all that is going to go over 1 minus the common ratio. And that looks like an H. Let me fix that up. It's making me crazy. So that's our formula. So in this case, n is going to be 20, right? The common ratio is the number we multiply by over and over. That's this guy, right? So he's going to be, R is going to be 2, okay? And then the first number, a sub 1, that's when we plug in 1 here for n. 1 minus 1 is 0, and that's typically going to be the case. And then 2 to the 0 power is 1, so a sub 1 is going to be 6. We follow all that? Yes, no, maybe? Excuse me. So then we just plug our numbers in. Go ahead and switch up colors here. So this will be S of 20 equals the A1 sauce, which is 6 in this case. And then 1 minus 2 to the 20th power. Yikes. That's going to be huge. Okay. And then over 1 minus the common ratio, which is 2. Okay. So here we go. But you kind of expect that if you're adding up numbers that you've been multiplying over and over, and you got 20 of them, yeah, there's going to be some seriously big numbers here. Okay. All right, so Calculator City. Yeah, I got the 6 from the original. Let's back up for a second. Because we got this sort of starting point, right? And we think that's going to be the starting point, but it's a sub 1, right? So that means if I put in 1 here for n, 1 minus 1 is 0, right? So you got 2 to the 0 power, which is just 1, and 1 times 6 gives you the 6. Okay, so yeah, that's where that came from. And then the n is this guy here, and then the common ratio is this guy here. Cool? All right. All right, so back to Calculator City then. So I'd start with the parenthesis part. So this is going to be 1 minus, here we go, 2 raised to the 20th power equals negative big ass number, BAN for short. All right, and then we're going to take that times 6. Yeah. So times 6, which is a BAN times 6, right? And then the bottom is 1 minus 2, so that's really just negative 1. So we're dividing by negative 1, which means we're really just going to switch the sign. And we get this wicked big number. All right, so we got 6,291,000. The rest I forget, 450. Now, can you imagine doing this and multiplying those numbers over and over and then adding all 20 of them together? Pass. Epic quantities of pass, right? So that's our boy right there. Okay. So again, I'm not expecting you to memorize the formula, just know where you can find it. Which, as you know, when we do our exam that they make us do at the end of the year, it's all open book, open notes. So look the stuff up. Questions? So it's just another formula, plug and chug. All right, party on. So this one you could probably do just because it's 7. You could probably do it the other way, or you could use the formula. We might as well use the formula since I went to all the trouble to look it up, right? So then we've got highlighter mode. That's what we've got. Now we've got eraser mode. See ya. All right, so let's go back to that. So this guy, so if we use our formula, we have S sub n equals A1 sauce and then 1 minus R to the nth power, and then all over 1 minus R. Okay, so in this one, n is going to be 7, R is going to be 3, and our first guy, so again, plug in 1 there, 1 minus 1 is 0, right? And 3 to the 0 power is going to be 1, and 1 times -4 is -4. So most of the time, as long as you got this n minus 1 thing going on here, your first number is just going to be this guy here. Okay, so then A sub 1 is going to be -4. So we're ready to roll. All right, a little color change. So this will be S of 7 equals the A1 sauce, which is -4. And we got 1 minus 3 to the 7th power, which will still probably be pretty wicked big. Okay? Wicked big, of course, is a technical term. And then we have 1 minus 3, which is just 2, -2, actually. Okay? So at this point, what you could do is you could say, well, if this is really -2, I have -2 over -4. These guys cancel out, right? They both become pluses, or a mess. And 4 divided by 2 is 2. So now this could really be just 2 and then times 1 minus 3 to the 7th power, which is going to be a wicked big negative number, okay? And the reason for that is by having the 4 out front, this is just going to keep being negative over and over and over. That's why you're going to get a really big negative number. But time for the calculator. All right, so we're going to go clear out this big number. We're going to go 1, nope, not 11, just 1, minus 3 to the 7th power. Boom. Not really that big. That was going to be worse. And then we just take that times 2. So minus 43, what was it? I forget. 4372. And a big old negative sign in front of it. Okay? You would have got the same answer if you'd done that part and then took it times -4 and divided it by -2. You'd have got the same thing. Okay? Questions? All right, let's rage on. Okay, so this was a little different, a little bit. But still the same formula, right? So I'm going to do S of n equals A1 sauce, 1 minus r to the n power. You know, the funny part about it is I'm really not a neat freak, but this kind of stuff drives me nuts for some reason. In fact, I'm quite the opposite as far as being neat. Ask my poor wife, she'll tell you. All right, so then this is 1 minus r. Okay, so n, that's usually our guy up here at the top, right? So n is 12. R, the number we keep multiplying over by over, is negative 4. Okay, so we got that guy, right? I put that parentheses around there to remind me of something. And then finally, the A1 sauce. Well, if we plug in a 1 here, right, we have 1 minus 1 is 0. Negative 4 to the 0 power is 1. And there's no number out here, so technically this is a 1. So the A1 sauce is, in fact, 1. Okay? Let's go ahead and plug these in. So we got, oh, that was the last one, was 7. This guy's 12. Can I do it? Close enough. S12 equals A sub 1, which is 1. 1 minus, now this is where we got to get a little weird, minus 4 to the 12th power. And then over 1 minus a minus 4. So that part gets a little weird, not gonna lie. Okay. So we got the 1 on top, and we got 1 minus a minus 4. Technically, that's 5, right? Because minus a minus is plus, so 1 plus 4 is 5. So let's call this guy 5. So what we got to do is we got to do this part up top here, and then we have to divide it by 5. All right, so calculator city. So this is going to be 1 minus, notice I did the parentheses. So I'm going to do the parentheses. I'm going to do 4 negative parentheses, and then raised to the 12th power. Okay, so something, yeah, this is okay. Because here's what the deal is. If you have a negative number and you raise it to the 12th power, that's 12 negatives in a row. Even number of negatives gives you a positive answer. So it's 1 minus a very big positive answer, in this case 16, almost 17 mil, right? And then our last step is, so that's all this stuff going on up here. And our last step is we're going to divide that by 5. Boink, boink, and boink. So it cuts us down to a measly 3.3 mil. I think I could still survive on it. Although I feel like that's my debt most days. So then we've got minus 3, what was it? Jeez. 3, 3, 5, 5, 4, 4, 3, I think. Hang on. Yep. 3355443. That's Mike Tyson's phone number, in case you're wondering. It's even 7 digits. That's funny. Questions? I guess my next question is, do you know who Mike Tyson is? No and yes? Mike Tyson was a fighter back in the day. He was a bit of an animal. He's still a bit of an animal. He's in the Hangover movies, if you've seen those. Okay. So let's check out a couple more. We'll call it a day. So this says write each series using sigma notation and find the sum. Yikes. Okay. So what do we got going here? How do we figure this guy out? So we could see we're going to keep multiplying, right? Okay. So let's do, it looks like we're doubling up every time, right? We're going from 8 to 16 to 32 to getting out of highlighter mode. We don't need to erase it. We can leave them, I guess. Let's just go over here and do another thing. Okay. So our number we're multiplying by over and over is 2, right? Now, if we do the thing like they did and do the n minus 1 thing, right? Then our first number, our a sub 1, right, is going to be 8. So 8 times 2 to the n minus 1, and we go from n equals 1 to n equals, we don't know yet. So how can we figure this guy out? Well, I could count on my fingers, but I've done this too many times. That's the problem. So we're at 8. So that's our first. 2, 16, 3, 32, 4, 64, 5, 128, 6, 256, 7, 512, and 8 is 1024. And again, you could do that on your calculator. Just count how many times you multiply by 2 to go from 8 to 1024. Or I suppose they have some sort of formula for this sort of thing. It would be my guess. Maybe they're just using the same thing we were using. Might be. So it might be if we use what we were using before. We don't know the sum though. Well, how the heck would we do that? Other than just count them. There's got to be a way. Okay, I figured it out. I had to think for a second. I haven't done this stuff in a while, as you can tell. So the last one is going to be 1024, right? And then what we've got going on here is we started at 8, right? And we raised that to the n. Well, no, not n, 2, because we're doubling up every time, right? Okay, let's try that again. So we're doubling up every time, so we're going to multiply by 2, and then it's the n minus 1 power. I was getting ahead of myself. Okay. So then what can we do? Well, first things first, we can divide by this 8, can't we? So we do that. Calculator City says 1024 divided by 8 is 128. So now we're saying 128 equals 2 to the n minus 1. All right. So if you guys remember, we were doing stuff like this before by using logarithms. Yeah, the logs are back. Time for another log jam. So we say log of 128 equals the log of 2 n minus 1 to the n minus 1. Now remember, the deal with the logs is we can turn this guy into a regular thing by putting it out front, right? So then we're going to have log of 128 equals n minus 1 times the log of 2. Next move, we'll come on up here. We divide both sides by log of 2, so we got log of 128 over log of 2 equals n minus 1. Running out of space rapidly. All right, so let's get the calculator out before things get too out of hand. So we go 128. We already got that up there. We say log. We get weirdness. Divided by 2. Log. We get more weirdness. Equals suddenly non-weirdness. 7, right? So we go 7 equals n minus 1. Add 1 to both sides to figure out what n is. N equals 8. Ta-da! So again, if it's not too outrageous, you can just start at 8, start multiplying by 2 till you get to 1024 and count up how many times that happened. Or we can do this logarithm thing. More fun than you thought humans were allowed. Questions? Yeah, that's good. Charlie hasn't run screaming from the room as far as I know. Could be a different story, though. I'm not really sure. Melanie, you with us? All right, Bailey. Looks like it's just you and me, kid. Let's do one more and call it. Ay, 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 ay. This one's scary. All right, so same deal. So first thing we need to do is we need to figure out, well, what are we multiplying by every time? So it looks like 42 divided by 7 is 6. But just for laughs, let's make sure. So for this one, we'll say, move over, please. Thank you. And again, they're all negative, so we don't really have to deal with the negative signs. So we go 252 divided by 42. Yeah, we're rocking with the 6. Okay, so let's do our sigma thingy. N equals 1. And then we've got minus 7 is our first guy, times 6 to the n minus 1. Cool. So the only thing we need to really figure out is this guy on the top, right? So again, how many times do we multiply by 6 to get 54, 432? Let's find out, shall we? All right, so we're going to start with negative 7. We'll count them up. That's where we're headed, right? So we've got 6 times negative 7. So that's minus 42. So that's our second guy, right? All right, then times 6. That's our third guy. Times 6. Fourth guy times 6. Fifth guy times 6. Seventh guy. So n equals 7. Oh, and then they want the sum. We didn't do that on the last one, did we? Okay, well, we can do that real quick. That was our other formula, right? Yeah, let's just do it for this one and call it, since we got the space. So the sum again, this is going to be S of 7 equals our A1 sauce, which is negative 7, and then 1 minus 6 to the 7th power, which is probably going to be another pretty big number, and then over 1 minus 6. Okay, so 1 minus 6, that's just going to be negative 5, right? So we'll come back to him here in a little bit. All right, so let's plug in the numbers. So calculator, I'm going to do clear it. 1 minus 6 to the 7th power, which I'm sure will give us a BAN. So rather decent size and negative. Then take that times negative 7. So BAN positive number, but then we have to divide by -5. So it's going to go back to being a negative number. All right. So minus 391,909. There we go. Okay. So again, we're using the formula. There's kind of a formula for this that we used here to get the answer we needed. Okay. All right. Well, we're getting close. Well, we're out of time. So next time we will wrap this up. So again, I want to thank you all for showing up, and hopefully we'll see you next time.